I read an article yesterday that in Turkish schools, evolution is taught up until the point where the apes and man come in. And then that is not taught. So evolution is all very well for other species, but not for humans.
Yeah, this is an interesting thing, isn't it, right? I mean, the dichotomy between people and animals people and mammals is a really strange one. I mean, you know, I've seen the insides of thousands of dead people, and I can tell you they're just made of meat, you know. And bones and the brains look like the brains of any other animal you put on the table, you know. So there's nothing different about what we're made of, and we reproduce in the same way, and we eat and defecate and urinate in the same way as most mammals, you know. So why people think that we're different at some fundamental level like that is crazy to me. I mean, I just can't understand it, but people do, right? And but it's also part of believing that the mind is something separate from the body too, and that's something I have a difficult time grasping. In Turkey, by the way, there's a rich man in Turkey. He came here to talk on campus a little while ago. He's a doctor, and he's got lots of money, and he throws it at the Turkish government and every other government. And he's published this giant, big encyclopedia that he mailed them to every teacher in the country here, I think, and overseas. And it's a huge, glossy, beautifully printed book that takes real fossil evidence and poo-poos it, right? So, for instance, a skeleton that I found that's 1.5 million years old, he says, no, it's just an ordinary person. See, it looks like a person. It does sort of superficially look like a person. It's a Homo erectus. And, you know, I can point out all the tiny details in which it's different from a human, but for a lay person to look at this picture, it looks like a skeleton. And that's the sort of stuff is done, right? A medical doctor, who are not taught any science, usually. Right? I know, because I used to teach them, right? Okay.
I grew up in central Illinois. I'm going on 83 now. I got through public school without ever hearing the word evolution. And I remember when I first became interested in it, I was in high school in Detroit, and I was experiencing a large city for the first time in my life. And I began to wonder whether people were still evolving, and if they were evolving to fit into this kind of an environment. And I remember in the 1940s, for the first time I saw reproductions of the paintings in Lascaux, in the caves, and I was knocked out by them, and I thought, I would love to hear the stories they told around the campfire. I wonder what songs they sang. And I got this idea, which is still strong in my mind, that we became human in the natural world, in the environment of the natural world. And now we're adjusting to a world that we ourselves have made. And I'm fascinated by the idea of, are we evolving to fit into this world now? And will it take us someplace altogether else?
Yeah, I'm not sure that we need to evolve to fit in. I mean, you know, the generations are so short. It's really interesting that now more people on this planet live in cities than live out of cities. And that's very strange for a primate, even a funny upright primate. It's more like seabirds living in giant colonies on the cliff, right? And the reason seabirds can do that is their food is in the ocean, and it's packed with food right next to them. So what we've done is we've brought the ocean to us, right? So we live in these big colonies of sort of monogamous groups, right? In a big packed in a city, and then the food is brought to us instead of the seabirds living in sort of monogamous mass groups on a cliff and finding their food immediately next to them. So it's a strange thing that we've adapted to, but clearly it's not taken. I mean, it's not taken more than a generation to. There's not enough time to evolve, right? It's just that we're adaptable enough in our society to manage it.
Hi. I was wondering if you could talk about the term transitional fossil and whether it is actually a real term. I've read recently that basically all fossils are transitional fossils, and it's just a term for creationists use, I guess. But
well, yeah, you know, I mean, if I went back in my own family, right, and dug up my parents and grandparents and so on all the way back and looked at all of them, you know, it's likely that I'd find some change just for random reasons, what we call genetic drift, if not adaptation. And so, you know, every one of them, if you looked at a lineage, would be a transition between one generation and the next. That's not a very profound idea, is it? Right? But I think what people are talking about here is when you have something like a whale, right, which is a large to medium-sized animals that have lost their hind limbs, got 4 flippers from 4 limbs. They swim in the ocean, they never come on land, they have their babies in the water. And then we know that they come from a quadrupedal animal that lived on land. Right? And actually, we have a wonderful sequence of everything from a small antelope-like, deer-like animal, all the way through to full whales. Right? There are some whale fossils that you can even see with Google Earth. There's so many of them lying out in the desert near Cairo. And they're Eocene, 50 million years old. I have a colleague who found whales, and the whales still had little back legs. These are from Pakistan, and they're something like 45 million years old. They have little back legs, and those back legs have little hooves on. Right? And this is a really interesting and surprising point. When molecular phylogenetics got going, that is, testing relationship by molecules rather than morphology, one of the most surprising results was, first of all, some Japanese and then later some people in this country, they found that hippopotamuses were closely related to whales, to the exclusion of all other hoofed animals with 2 feet. Right? So all the pigs and antelopes and bovids and all those other things, deer and cows, were all away from that. And hippos, which are always thought to be closely related to pigs, were closely related to whales. And the paleontologists and comparative anatomists didn't like this a bit, right? And this was in the early days of molecular phylogenetics. They didn't like it. And more and more people kept doing the same molecular work and finding the same conclusion. And then my colleague found the little legs with hooves on. And the ankle bone in these sorts of animals is very characteristic. And the whales these whales with tiny back legs had a perfectly miniature ankle bone like these early artiodactyls. So the paleontologists were then convinced that the molecular people had got it right. So it's an interesting form. But the whale story is perhaps the easiest to notice because it goes on for such a long time before whales become the whales we know today. And the intermediates are rather like, well, the first whale-like animal is a quadrupedal animal that lived on the land all the time. The second animal looks something like a sea lion with big hind flippers and moved in an undulating way like a seal or a sea lion. And then and was a half in the water, half out of the water animal. And then the next ones are developing more front flippers, and the hind flippers are disappearing, and a fluke is forming on the tail, and so on. So the story, we could document the whole sequence. And one of the reasons we can, why we can't do that for humans, is when whales die, they die in water, right? And they can get buried in sediment, and we can find them because we have sediment. When humans die, we die on land usually, and humans are edible. We get crunched up by our scavengers. And so we don't find skeletons of fossil humans except extremely rarely, right? There's one you know about called Lucy, which is about 20% of a skeleton, and there's one that I found, a Homo erectus skeleton, which is about 40% of a skeleton. And then there's this Ardipithecus thing that was found recently, and those are the 3 main skeletons of early stuff. Right? So the whale story is classic just because of the luck of sedimentation.